So include the header file, then begin the main function. Okay, so start the main function here now. So if we want to test whether a given number is even or odd, okay, so how do we test? First we need to read the number from the keyboard. So for that you declare a variable. Okay, assume num is a variable where we store the number. Okay, so then we need to test whether this num is even or odd. Okay, so first ask the user to enter a number. Okay, so say enter a number. Give a prompt message to the user to enter a number. He entered some number. Okay, now read that number using scanf function. Okay, so scanf, then say percentage d comma address of num. So store the number entered into the variable called the num. So now the variable num contains the number. Now we need to test whether it is an even number or odd number what the user has entered. Okay, so how to test whether it is even or odd? Is it clear now? Is it okay now? Why is okay now? Why is still not clear? Voice quality, how is it? Okay now? Please the settings here. Is it okay now? Still low voice. Okay. So when you went with 2, then if the remainder is 0, then we'll decide that it is even number. Otherwise, we say it is an odd number. Okay. No. So how to test that? How to write statement in program? Okay. So then we need to test condition. Immediately, condition means we have to use if statement. If, okay. So then divide and get the remainder. Okay. So what is the operator used to get the remainder? Modulus operator. Okay. So then num mod 2. Num mod 2. What it will do? It divides the variable num with 2 and gives that remainder. Now you check whether that remainder is equal to 0. Double equal to you have to use. Okay. Whether that remainder is equal to 0. Okay. Yes. So if it is equal to 0, then you say it is an even number. Okay. So directly print here percentage d is an even number. Percentage d is even number, comma, then say num. So percentage d, where from it has to print? From the variable num. Else, otherwise, if the remainder is not 0, directly you can confirm that it is an odd number. Okay, so we don't bother what is that remainder. Generally, when you divide with remainder, you will get only either 0 or 1 as remainder. Okay, so this is the logic in mathematics. For example, if you divide a number with another number, okay, so 3 with 3 if you divide, then the possible remainders may be 0, 1, 2. With 4 if you divide, the possible remainders may be 0, 1, 2, 3. With 5, 0, 1, 2, 3, 4. Okay, so with 2 means either 0 or 1. These are the reminders you will get. Okay, so our intention is if the remainder is 0, when we can say that it is even number. Otherwise, we can directly say that percentage d is an odd number. Is an odd number. Comma, num. Okay, so then say return 0. Return 0. That's it. Then end your main program. Okay, so these are the 5-6 lines program. So are you able to write this program or not? You test yourself. Okay, so this is important. Writing program on your own. This you should develop. Okay. Is it okay now? Now, what happens? Just we'll see this program. Okay. So if I execute this program, just let me build. I'm building the program. Okay. So 0 errors. If I run the program, now see the output here. Enter a number. Okay. So for example, I enter 5 there. Now see 5 is an odd number. 5 is an odd number. Okay, so if I run the program again, enter a number. Okay, so this time 8 I entered. Now see, it is an even number. Yes or no? Okay, so with any kind of input. Okay, so you can enter any number here. Okay, so 9 if you enter, 9 is an odd number. Okay, this way you can test the program whether it is an even number or a odd number. Okay, all right. So this let me copy here. Right. Now I can share this with the PDFs. Right. Now, now we'll proceed with the else if ladder. The fourth form of if statement is else if ladder. Okay. So this else if ladder, when we use this else if ladder, it is a multi-path decision statement. Please remember. Okay. So we have seen simple if statement. Only when true condition, if you want to execute, then we use simple if statement. Then alternate decisions we want to take. Means when it is true, one action. If it is false, another action. If we want to perform, then we use if else statement. Okay, so nested if else statement, that means more than two decisions are involved. Okay, so then we use nested if else statements. We have an example for that greatest of three numbers program. Okay, then a series of decisions involved. A series of decisions are involved. Ultimately, you have to come up with a single decision. Then we use this else if ladder. That's why it is called multi-path decision statement. Multiple decisions are involved. Okay. Now that is what, when a series of multiple decisions are involved, the else if ladder form will be used. It is a multi-path decision statement. Multi-path decision statement is what? It is a chain of if statements. A multi-path decision statement is, it is nothing but a chain of if statement in which the statement associated with each else is an if statement. That means immediately after else you will get an if. Immediately after else you will get an if. Okay. So in that way, else if, else if, else if kind of a statements will write. That's why it is called as a else if ladder. Okay. So the syntax of else if ladder, if we look into, or the general form of else if ladder, if we see, now see here. So if it begins with a if, and within the brackets condition 1 will give. If this condition 1 is true, statement 1 is executed. If condition 1 is false, then it goes to else. And immediately after else again, the statement is if statement again. If condition 2 will test. If this is true, statement 2 is executed. And condition 2 is false, then it comes to else again. Okay. So with this else again, the associated statement is if statement. If condition 3 we test. If it is true, it is executed. If this is false, then it goes to condition 4. Like this, we can write n conditions. We can write n conditions. Okay. So in finally, else if n will test, this statement n will be executed. Okay. If finally this nth condition is also false, then finally this last else will be executed. Default statement. This is the statement executed. All n conditions are false. Okay. Condition 1 false. Condition 2 false. Condition 3 false. Condition 4 false. Condition n false. Then finally it comes to this final else statement, and the default statement will be executed. Okay. Now how it executes, then the next statement is statement X, continues it with the next statement. Okay. Now see, we have n conditions to be tested, and finally only one condition will become true here. Okay. For example, if condition 1, if this is true, statement 1 is executed, from here directly control jumps to statement X. It directly jumps to statement X. Let me just see whether this can be copied. Right. Okay. Now see here. This is the general form of a if else a ladder. Okay. So I'll increase the font size so that you can clearly see this. So it is visible to you. It is visible to you. Okay. So this is else if ladder. Now see here, else if, else if, else if, with each else the associated statement is immediately an if statement. Okay. So that's why, and it looks like a ladder, that's why it is called a else if ladder. Okay. So how this is executed, let's see here how the control jumps from one point to another point. Okay. So first condition 1 will be tested here. If this is true, statement 1 is executed. Okay. So then after immediately after executing statement 1, control directly jumps to statement X. Here, it directly jumps to statement X, skipping rest of the ladder. Okay, no other statements are executed here. Okay, so directly it comes to this statement X here. Okay, so because condition 1 is true, the associated statement 1 will be executed. Then it won't come to this else. Okay, so directly it jumps to statement X here. Directly jumps to statement X here. Voice is not clear. Okay. uh, okay, okay, right. So sometimes the internet connection is getting fluctuated. Okay, so that's why you are getting low voice, maybe. Okay, but not an issue. Okay, right. We'll proceed with this. Then, if condition one is false, then only it comes to this else part. Okay, so in this else, the next statement is again an if condition. If condition two it tests. If this is true, then statement two will be executed. Okay, then after executing, okay, talk slowly. There will be gaps in the voice. Right. Condition one false means it's come to the first else statement. Then again in this condition two is tested. Okay. So if this is two, statement two is executed, and from here directly the control jumps to statement X. From here it directly comes to statement X here. It goes to statement X, skipping rest of the ladder. Okay. If condition two is false, then it comes to next else statement. In this again, condition 3 we are testing. Okay, if this is true, statement 3 is executed, and from here directly control jumps to statement X, skipping remaining statement. Only one statement will be executed. Please remember, observe the execution path. So like this, it tests if this condition 3 is also false, it comes to this else part. Then condition n it tests. Like this, you can write n conditions. Condition n is true, then statement n is executed. Okay, goes to statement X directly. And finally, this n condition is also false. Then comes to last else, then executes this default statement. After that, immediately the next statement is statement automatically the control goes to the next statement, statement X. Okay, so this is the execution path of a else if ladder. Okay, so series of conditions we want to test, and only one condition becomes true, and only the associated statement will be executed. Okay, in such case, we use this else if ladder. We use this else if ladder. Okay, right? So when we use this else if ladder in real time, and where we use in we want to use this in the programming. Okay, so for example, we want to find the grade of a student. We want to find the grade of a student. Okay, so like a distinction, whether a student has got distinction, first class, second class, third class, or fail based on his average marks. Okay, a student will get only one grade, but there are different categories of grades. Okay, so in such situations, we can use this else if ladder. Okay, so a program, if I want to uh, demonstrate for this else if ladder, okay, so it is finding the grade of a student. Okay, right. So now just program, we'll write a program for this. Okay, so program demonstrating else if ladder. These are keywords, and always we have to write them in a lowercase. Okay, so how we can demonstrate by using this program. Okay, so program to find grade of a student based on average marks. Based on his average marks. Okay, so if the uh, grade and average marks are given in this form. Okay, so for example, say average mark and grade are given in this form. Okay, so say average marks are between 80 to 100. Okay, so then we can say that the grade of the student is distinction. Yes or no? Okay, so above 80% means this grade is distinction. Then if the average marks are between 60 to 79, 60 to 79, then his grade may be first class. Then average marks are between 50 to 59. Okay, assume they have classified grades according to these rules. Okay, so then student may get a second class grade. Okay, then if average marks are between 40 to 49. Okay, so assume the student is awarded with a third class grade. Okay, and finally, if average marks are less than 40. Okay, so if it is less than 40, then student is awarded a fail grade. Okay, so fail. Like this, they have given the categories. Okay, now if such a categories are given, now we need to write a program which prints grade of the student. Grade of a student it prints. Okay, right? So we'll write the program for this. Let me copy this. A.cm saving this. Okay, so finding average marks. Now I'm writing program for this. Okay, so include the header file, stdio.h. Okay, so then write the main function, then begin the main. Okay, now begin the main here. Okay, so we need to read a student to average marks or not. Okay, so for that I am declaring an integer type variable. Okay, or if you want average marks to be float, you can declare a floating variable here. Float marks I have declared here. Okay, so now ask the user to enter average marks. Okay, say enter average marks of a student. Okay, so then read that average marks. Say percentage f comma address of marks. You store the value in a variable called as a marks. Now the student marks are stored in the variable marks. Now we need to decide what, based on his average marks, whether he is getting distinction, first class, second class, third class, or a fail grade. Which grade he is getting? Okay. So first, test whether student is getting distinction or not. Okay. So if you want to test the condition, what we need to use? If statement we have to use. If marks, if marks. Okay. So if marks greater than 79, if marks greater than 79. Okay, so what is the classification of grades? Between from 80 to 100 it is distinction. See here, from 80 to 100 it is distinction. Okay, so if we write greater than 79, that means all the marks which are between 80 to 100, between 80 to 100. Okay, so if marks greater than 79, then you print here, say printf, directly say, just say distinction. Okay, otherwise that means students are not between 80 to 100, then you check whether he is getting first class or not. So again, if this false, then write else for that, and immediately again we need to test the condition. So again, this else immediately follows a if statement, and please remember there should be a space between else and immediately if statement. Okay, so else if, now say marks. Okay, so greater than, what is the second category here? Marks greater than 59. So marks greater than 59. 59 means 60 to 79, this category. To 69. Okay, so then it comes to this category. Okay, so if marks greater than 59. Okay, so then print here, because this printf belongs to this if statement. Okay, so that's why you write below this if statement. Now you say printf first class. So grade is class. Otherwise, okay, so else, this else is related to this if statement. So that's why exactly below this if I'm writing this else statement. Now see here. Okay, first class kuda kaadu. Then you check whether he is getting second class or not. So how to test the condition again? If marks greater than, what is the third condition? 49. If marks greater than 49. Okay, so that means 50 to 59 category. Okay, so then that means is awarded the second class. So within the printf statement, write second class. Okay, otherwise now you test whether he is getting third class or not. Okay, so exactly this else belongs to this if statement. This else belongs to this if statement, and this else belongs to this if statement. So that's why you have to write else statement belonging to corresponding if statement exactly below that if. Okay, if again test the condition. Okay, so if marks greater than, what is the last condition? If marks greater than 40. Okay, so 40 means 39. Okay, so if marks greater than 39, 40 to 49 category this belongs to. Okay, so then you say printf third class. So his grade will be third class. Okay, otherwise else. That means all the conditions are false. Okay, so that his marks are below 40. Okay, so directly you can declare that he is a fail. His category is fail. Okay, so then finally you say fail. Then return 0. Return 0. Okay, so this way now you can see else if, else if, else if, else. Okay, it's like a else if ladder. That's why it is called a ladder of else ifs. It is called else if ladder. Okay, like this, and series of decisions are involved. Series of decisions are involved. We use this else if ladder, and you should come up with only single decision. Okay, so in such case, we use this else if ladder. Okay, now if you see the execution of this program, let me build the program. Right, let me build the program. Second class, first class. Okay, so backslash n. Okay, so that your next output will be in the new line. Thank you. Okay, right, new line I missed here. Right, so I'm just executing this build the programs, give errors. Now I can, okay. Enter average marks of a student. Enter average marks of a student. Okay, so now you tell average marks. Okay, so something like we'll start with the distinction. Okay, so 85.6. See distinction. Okay, so that means the student grade will be distinction. Okay, now again I run the program. You need to test all, for all categories you need to test your program. Okay, so that means all test cases, possible test cases you have to use for testing the program. Okay, so one test case you test and don't think that your program is giving correct output. Okay, sometimes it may fail for other test cases. Okay, enter average marks of a student, say for example 68 average marks. Then first class, 60 to 80 in between we say first class, the student may get a first class. Okay, so similarly you can enter average marks. Okay, so for 59 for example, second class, even 59 also second, 9.9 also second class. Only when he gets 60%, then he will be awarded a 60 marks, first class. Okay, so then run, enter average marks. Okay, so even now see here 39.99, even if you get a first class. Okay, so what it is doing here, it is rounding off and to 40, and that's why it is giving a third class. This is the problem with the floating pointer numbers in C program. So automatically the computer, what it will do, 39.99, it round offs to 40 and printing the third class here. Okay, so what is this third class? Where is this? Yeah, 39.99. 39.99 is greater than 39. Third class it is printing correct only. Okay, so fail means below 40. Something we are missing something. First see the categories. Yeah, 79 and above it is distinction. Okay, so 60 to 79 first class, 50 to 59 and 40 to 49. 40 to 49, it is third class. Okay, so below 40 it is 50K. Okay, so something we are missing here. Okay, so greater than 79, 80 to 100 is 79 here. Okay, so 60 to 79 it comes here. Then this is third category, 50 to 59. Second class means 50 to 59. Okay, so then third class means 40 to 49. Okay, so marks greater than 39. Okay, so I think, 40 to 49. Here it is failing with the 40 here. Okay, so then you should round up all of them to 79.99 will become greater than this. Okay, but it should be 80 here. So then what we do is we change these to left hand side. Floating point number we enter now. Then it becomes wrong. Okay, but here if it is a floating point number, then you have to use 60 here. Okay, so then you should use 50 here. Okay, so then you should use 40 here, and below 40 then, and even if it is 40 third class. Okay, so then what you have to use, greater than or equal to 40. Okay, so marks greater than or equal to 50 means second class. Okay, so then equal to 60, greater than or equal to. We have not used this. Okay, so when you test, you will come to know what is the flaw in the program. You come to know the mistake you committed in the program. Okay, so now if you correct this, then you get the correct output now. Previously what is happening, now these are the rules here. Now see here, these are the rules. If you see the rules, I'll explain once again. Now understand the rules here. Below 40, okay, so 40 below, the category will be free. Okay, that means even if you get 39.99 also, okay, from 40 to 49, third class, you will be awarded a third class up to 49. Okay, so if you get 50 to 59, 50 to 59, okay, so 50 to 59 means second class. That means greater than 50 and less than 60 here. It should be greater than 50 and less than 60. Okay, so it should be written again. The condition should be uh, changed. If it is a floating point number, if it is an integer, then these categories works. Okay, right. So instead of these things, now what I do is a rounding of 100 plus also there is, that is what bug in the program. If you enter 100 plus, what happens, it gives fail because all conditions it finally comes to else here. Okay, assume that we are entering a average marks. Now you can see here marks greater than or equal to 80. From 80 above, it is distinction. Okay, so from 60 above, it is first class. From 50 above, it is second class, and 40 above, it is third class. 40 and above, third class, and below 40, it is fail. Below 40, it is fail. Now if you enter 100 plus 105, you enter here. Marks greater than 80, no, this fails. Marks greater than 60, fails. Marks greater than 50, fails. Marks greater than 40, fails. And finally it comes to last else statement. This is the statement executed when all conditions are first, the first statement, and finally let fail here. Okay, if you want to handle this case, you need to write another condition here. Okay, so you should ask the user to enter average marks between 0 to 100. 0 to 100. Okay, so then you have to say invalid input. Okay, so how that can be handled here? Okay, so first we'll test this program, then I'll tell you how to handle such situations. Okay, more appropriate program that is. For here, this is enough. If you write a piece of code in this form, it is enough. Okay, but all cases if you want to 100, because marks are never be less than 0 and never be greater than 100 average marks score. Okay, so that case also, if you want to handle to avoid errors in your program, then you can write one more condition and you can test it. Okay, so how it can be written, just see here. So first you need to test here marks if marks less than 0, or you have to use logical or marks greater than 100. Okay, if any one of this condition is true, then immediately you print it here, say printf invalid input, invalid input. Okay, so now you can give a message, please enter please enter between 0 to 100. that way you can request the user to enter the number between 0 to 100. Then he understands that I have committed a mistake. Okay, then immediately you want to come out from the program. Okay, otherwise it goes to the next statement. So from this point, if you want to come out from the program, there is a function called as exit. There is a function called as exit, and within the parenthesis give 0, exit 0. Okay, and when this is the case, these two statements are executed. So that's why you have to include this in parentheses or braces. You have to make it as a block. Make it exit 0 means immediately the program comes out from this point. Okay, so otherwise if you enter between 0 and 100, then it checks the first condition, it checks less than 0 na, no, greater than 100 no. Okay, so both are false. False or false is false. Then this is simple if statement, no associated else is there, so directly it comes to the next statement, and the next statement is this one here. So again it checks this series of if statements, then the corresponding grade will be printed here. Okay, so now is it okay now? So now your program also handles the number. If you enter a number less than 0 and greater than 100, then is softly it says invalid input and please enter a number between 0 to 100. Okay, so now you see the different outputs. Once again, yeah, what I do is I'll explain on the board so that it becomes easy. Now I copy this program. Paste this here. Okay, all right. Now see here, I'll explain here. Okay, so enter average marks. Now this is marks. Okay, so when you declare marks, okay, assume for marks memory is allocated like this. Okay, so assume this is marks. Right. Yeah, so it's struck on the as a poor network quality at my end, I think. Okay, network fluctuations happening here. Right. Now we'll handle this case. Now see, enter average marks of a student. For example, you have entered average marks 100. Marks means all subjects total divided by number of subjects, that gives average marks, and average marks always less than 100. Okay, if you enter 120, what happens we'll see here. Okay, so that 120 I am catching in a variable called as marks, then it immediately it comes to this part. Okay, so it checks here if marks less than 100, 120 less than 100, no, this is false. The first case is false. Or marks greater than 100, then this becomes true. So in our truth table, if any one of them is true, then the result will be true. Okay, so that means this condition becomes true here. Then it enters this if statement. Then it prints invalid input. Please enter a number between 0 to 100. This is the output printed. Then it comes to next statement, exit 0. When it says exit 0, directly it comes out from the program. It won't go to the next statement. Okay, from this part your program will be terminated. If you don't write exit 0 here, it goes to the next statement here. Again it checks these conditions. It checks these conditions also. Okay, so you will get two kinds of output, invalid input and something like distinction or first class. Both will be printed, which are valid. Okay, so that's why after invalid input, your program has to come out by printing this invalid input. Okay, so see the output here. Now see. Now if I run the program, enter average marks, say 120 I entered. Now see, invalid input, please enter between 0 to 100. Okay, so what is happening there? Printing this printf statement, immediately it is this exit 0 causing your program to terminate. From there it is coming out. Okay, right. So again, if you enter a number less than 0 also, now see what happens. Say minus, and if you enter, just see here, invalid input, please enter between 0 to 100. Okay, this is how you can handle some invalid test cases. On these cases, it prints fail, fail, fail. And if you run the program again, and now if you enter 39.99, okay, so because you are reading only integer data, now 39, then it says fail. It says fail. Okay, so if I remove exit 0 and what happens, I'll show here. Okay, so for example, exit 0 I'm removing here. Okay, so because there is only one printf, actually these things are not required. Okay, anyhow they are available, and keep them as it is. Okay, so now I removed exit 0. Now we'll see, we'll build the program again. Okay, so let us see. Zero errors. Okay, right. Now I run the program. Now see. Okay, so what number I should enter? Same 120. 120 I should enter. Okay, so write 120 I enter. Okay, now see. Invalid input. Please enter number between 0 to 100 and see distinction. Okay, so where from this output printed, that you should understand here. Okay, now if you look into our code here, now what is happening, just see here. Okay, so when this exit 0 is not there, okay, so I removed this exit 0, assume. Okay, now what happened here, 120 means this condition is true. True means it prints this input. Now after this, because there is exit 0, the default path is going to the next statement. The default execution path is going to the next statement. Okay, so after the end of this if statement, control comes to this. Okay, so it goes to the next if statement. Then again it prints here. Okay, so now it goes to this next if statement here. Just see here. Okay, so if marks greater than or equal to 80, marks is 120 greater than or equal to 80, yes, then this printf is executed and it prints distinction. Then from here directly else ladder is skipped here. Okay, so it won't go to this else if ladder and directly it goes to return 0 and your program ends. Okay, so directly it is 0 after printing this distinction. Okay, so that's why you can see both outputs there. Okay, so invalid input and distinction. If you write exit 0, then it won't come to this piece of code. It won't come to this piece of code. From here it comes out. Okay, so that's why we use exit 0 to come out from the program sometimes. Okay, this piece of code I don't want to execute when this is true. Okay, so this is simple if how it can be used. See here. Only true case, for true case we are executing some action. For false case we don't bother. Is it clear? Okay, so this is an example of else if ladder. Okay, so the four forms of if statements we discussed. Simple if else statement, if else statement, when action, for true case one action, for false case another action. Okay, so two actions, alternate actions when we want to perform, then we use else if else statement. Then nested if else statement. More than two decisions are involved. Okay, so in such case we use nested if else statement. Greatest of three numbers program we have written. Okay, so then a series of decisions are involved and only we need to come up with single decision. Then we use this else if ladder form. Okay, so these are the various forms of if statement. Based on complexity of the program and the type of program, we use one of these forms of if statements in the program. Okay, okay. So right, so if it's clear, then we'll stop here because audio quality from my microphone is poor. Okay, so we'll stop here. Tomorrow, what I do is I discuss about switch statement and loop statement like while loop, for loop, and do while loop. Okay, so hopefully tomorrow I'll take second hour and fourth hour, and we'll try to finish these loop statements. Okay, so PDFs. Okay, PDFs I'll send now. Okay, so we'll stop here. Thank you, one and all, for joining the class. Right. You can leave now. You can leave now. It is showing bad network quality. Yeah, that's why I think causing poor quality network. Okay, bye. Thank you, everyone.